This is our second video, and just to explain, the point of this channel is to split between homeworks and the actual concepts taught in class. So as you may have seen in our previous video, that was a video going over homework, where Evan mentioned many formulas which you may not have known where he got them from. And the point of the concept videos is to compress everything that's taught in class so that you can still get the same knowledge, but in a normal amount of time, and actually understand what it is instead of getting confused in class. So we're going to start at where the very beginning of the unit was, which was with, as you can see, vectors versus scalars. And this is going to be a rather short video because the topic isn't long. So scalars and vectors. So now, what is a scalar? A scalar is simply a term, this simply refers to any sort of unit that only requires something called its magnitude, which is just the number that accompanies it. So for example, mass is a scalar because mass is just the amount of stuff we have in the substance, essentially. Now, we can measure mass in grams, but no matter what, the mass of anything will always be the same, no matter where it is. Now, why this is a scalar is because we only have a number, say it's 3 grams. This is just the mass of something that's 3 grams. However, if it were a vector, this would only be, this would only be 3 grams on Earth, because this is something we know as weight. A vector is, well, simply put, a magnitude accompanied by a sort of frame of reference. For example, mass is always 3 grams, but the weight depends on what planet you're on. So on Earth it may be 3 pounds, but on Mars it may be 1 pound, or on the moon it may be half a pound. Sorry, grams. But this is why, because the vector is the magnitude accompanied by its frame of reference. I'm just going to write EAR. Now, let's take another scalar. For example, here, speed. So speed is a scalar because no matter what direction you go, it'll always be positive. It'll always be a speed. So let's say we just have the speed 5 meters. Oh my god. 5 meters per second. So 5 meters per second simply refers to the fact that something is moving at 5 meters per second, relative to the Earth at least. But if I go north 5 meters per second or south 5 meters per second, it's still 5 meters per second. If I'm driving a car, it's not going to say that I'm going negative 5 meters per second if I'm going south. However, the vector version of this is velocity. And velocity, unlike speed, depends on not only the magnitude, which is 5, it's just a number here, depends on not only this magnitude, so 5 meters per second, but it also depends on a direction, meaning the velocity needs to be going somewhere. So let's use our frame of reference being just north. So that means that positive, we have 5 meters per second. We're going north at 5 meters per second. Now, if we want to say we're going south at 5 meters per second, we have to say we are going at 5 meters per second south, or maybe east or west, doesn't matter. And as we will get into later in Regents physics in general, we're not going to be measuring velocity with these kinds of directions, but we're going to be measuring it with degrees. So for example, you might be moving 5 meters per second at 40 degrees, meaning that, given that this is 0 degrees, right? This line is 0 degrees, you're going to be moving this way at 4 meters per second. But we'll get to that later when we talk about vectors just by themselves. And what other examples of just scalars that you may have seen on our U-Texas homework a while ago might be like age and time, because these will always be the same no matter what, well, with small exceptions, but these will always be the same. Another good example of a vector and, well, a scalar, which is also a vector, is acceleration. Now, just like velocity, just like speed, acceleration by itself can just be 5 meters per second squared. We can go over what acceleration is in a second. But this doesn't matter. It's always going to be 5, which is just the magnitude. So remember, this number here, this is the magnitude. That's a very bad arrow. I think you can see what I'm pointing at. So that's what a scalar is, just the magnitude itself. So no matter what direction you're going, it will always be 5 meters per second. However, when we treat acceleration as a vector, which unfortunately is still named acceleration, now it depends on which direction you're going. Although you will see much less of, say, what angle you're going at, like 5 meters per second squared, 50 degrees. But what you will see a lot in at least the next few weeks, I guess, of physics is that we're going to be treating acceleration as either positive or negative. And that's because our frame of reference is just the Earth and using it as down. So when we go up or away from the Earth, up means positive acceleration. But when we go down, that means negative acceleration. Because, simply put, we're going closer to the Earth versus farther. These are just our frames of reference, which you should understand from class. Why this matters, you'll be treating this as one of the constants you'll use the most is something called g, lowercase g, which if you look at your reference table, equals negative 9.81 or 806 or whatever it is, meters per second squared. Now what this means is simply that every second your velocity will be increasing downwards or increasing in the negative direction by 9.81 seconds, because how we actually write this is negative 9.81 meters per second, meaning that this is our velocity, and it changes just by this much every 1 second. And that's that. And then there's one more that we want to go over, which is, of course, distance. As a scalar, distance is simply just the distance, right? We measure from point A to point B, and say maybe it'll be 5 meters. But it'll be 5 meters, and that's that. But if we use it as a scalar, it's called position or displacement. Let's call it displacement for now. So now we take our magnitude 5, and we have to use it. So we need a frame of reference. So say we use A as our frame of reference, right? This means that all of our movement is in terms of A. And of course we have to set like an axis here. So let's say this way is negative and this way is positive. And if B is here, that means that this distance, this displacement, B has a displacement of 5 meters from A. But C over here, C has a displacement of negative 5 meters because it is in this direction. The frame of reference is A. Whereas in the distance, A and B and C are all just 5 meters away.
Additionally, you should note in the scalar measure that its distance, if you were to try to go from point A over here to point B, following this path, going over this AC line and then over this CB line, with distance you would be adding those in order to calculate how far you've gone. So that would be 14 in this example. Whereas with displacement, the vector measurement, you would simply use the distance that you actually traveled to get from point A to point B, which would be 3. So this is 14 would be distance, and 3 would be displacement. Assuming, of course, that you follow this path this way.
And that is essentially all there is to know, at least in the beginning of Regents physics, about scalars and vectors. And you'll see these being used a lot in the next few units/videos, in which we're going to be using vectors to describe a lot of motion with the kinematic equations. But yeah, and if you have any questions, feel free to ask either Evan or I, and we'll be willing to help. Yeah, I hope this video helped.